Many parametric tests rely on assumption of normal distribution, and when using these tests it might be a good idea to test your data for normal distribution or actually non-normal distribution to see that the assumption is met. One way of doing this is to make a probability density plot using the density command. And in this example we load the warfarin dataset and put it in D, and we then want to make a normal density plot of the ages of all patients by using the plot command, and what we're plotting is the density. We use the density command here and provide it with, as an argument, the age column. This results in the solid line here, which may tell you that this is not normally distributed, but it's easy to see if you also add a real normal distribution, a Gaussian curve, which indicates the shape of the curve had the $h been fully normally distributed. And to get this into your plot, you can use the curve command and then draw a curve of d norm, which gives you a normal distribution based on a few assumptions. We start here by giving x as the first argument, and there is probably a good reason for this, but it's enough to know that there has to be an x here. Just write it. And then you provide r with the mean and the standard deviation, and we set the mean here to the mean value of the ages and the standard deviation to the standard deviation of the ages, because had the $h been normally distributed, then the mean would have been the mean of all values and the standard deviation would have been the standard deviation of all values. We use a dashed line and we add this argument add equals true in order to get the curve in the already existing plot rather than replacing it. And as you can see, the two curves differ a bit and the ages are probably not normally distributed. Another way of looking at the distribution is to use a quantile-quantile plot, which is a commonly used plot to check for non-normality. And you get this plot by using the QQ-norm command and then simply the data, the $h. And if you want this line here telling you where the values would have been had they been normally distributed, then you use the QQ line command to get this line. And the plot basically calculates the quantiles for each observation and then plots the observed quantile here against the theoretical quantile, the quantile it would have had if the data had been normally distributed. And this gives you a lot of information, this plot, about kurtosis, skewness and such things. But I won't go into that, and here it's sufficient to say that the ages are not normally distributed because they diverge quite a lot from this line. You may also want to use some sort of test, a formal test to tell whether the data is normally distributed or not. And one such test is the Shapiro-Wilk normality test, which is accessible through the shapiro.test command. And you simply give the column containing the data here. And in return we get a p-value which is very low, indicating that the ages are definitely not normally distributed. But if you would have a rather small sample, then this test could have a low power and you may not be able to detect the non-normality, although it's there. If you want to look for kurtosis or skewness, these are available, but you would have to load a package, for example the moments package.